Let's look at a couple more examples of volumes of solids of revolution, but now we're going to be looking at areas contained between two functions. So here we've got the area between graphs of the functions y equals 4x and y equals 2x squared, and it's rotated about the y-axis to form a solid of revolution, and we're told the volume is v units cubed, so we're interested in volume. So from our previous examples, remember we had to think about number one, was this a volume or a surface area? It's a volume. And number two, which axis are we rotating around? So there are two considerations. But now, because we're looking at the area between two graphs, we have a third consideration. We need to consider which graph is above the other. So although this is a Queensland exam question, let's treat this like a paper 1 exam question where we don't have a calculator. So to know information about what the graphs look like, I think it would be helpful to do a quick sketch. Okay, so we've got our linear graph there, and let's then draw our parabola. Not the best, but it works okay. Like x squared. Now for the intersection points, let's let 4x equal 2x squared. So we'll pop it over the same side, take out 2x. So that therefore gives us x equals 0. That makes sense, that's the origin here. And we've got x equals 2. So that would be 2, and if I pop that in there, the y-coordinate will be 8. Now, here's the bit where you need to pause for a moment. Sometimes when we've gone to this point here, people will go into a bit of autopilot. They see two graphs and they see this is the area between the two graphs. That's going to be the area that we're rotating. And then they automatically go to rotate it around that x-axis. So they'll see that the straight line 4x is on top and y equals 2x is underneath for the interval between x equals 0 and x equals 2. However, remember, this question said that we're rotating around that y-axis. So that means we're going to be rotating in this direction around the y-axis. It's like the axle of our wheel. So because we're being mindful that we're rotating around the y-axis, the parabola y equals 2x is going to be the one that's furthest from the y-axis. And we have our linear graph y equals 4x, that's going to be closest to the y-axis. You could also tilt your head to have the y-axis horizontal and look at which graph is above and which graph is below, if you find that easier to imagine. So we are rotating about the y-axis, so that means when we're finding that volume, it's going to be pi, and we said we're interested in the y-axis. So we're going to have dy at the end, meaning our terminals are going to have to be from where y goes to. So instead of being from 0 to 2 in the x-axis, we're going from 0 to 8 in the y-axis. But if we want to, let's make this general to start off with. So let's go from a to b. We're going to have, we'll call it x1 squared minus x2 squared. Now, we need to rearrange these equations. Instead of it being y equals 4x and y equals 2x squared, we need to rearrange these to be in terms of x. So that means for this one, we're going to have x is going to be y on 4, or you could have had a quarter y. And for this one, x is going to be, we divide by the 2, then take the square root. So we're going to have y over 2 and the square root. And we're just taking the positive square root here because we're just interested in the positive regions there. We don't need to look at these negative regions because they're not of interest in our situation. Now, we want to have the graph that is further away. That's going to be the thing that we are going to signify as x1. And we said that was the parabola. So that means this rearrangement is going to be x1. And the linear graph, this is going to be x2 for the purposes of our substitutions in here. Oh, let's not get rid of them yet. So we're going from pi. We said we're going from 0 to 8 because we're interested in the y values. We've got a dy at the end. Then x1, we said was the square root of y over 2 squared. Okay, nice. And then x2 was y over 4, and we need to remember to square that. Let's continue. So 0 to 8, that's nice. We get y over 4 minus y squared over 16. if we wanted, so that will give us y over 2 minus y squared over 16. If you felt partial, you could take a half out as a common factor. So that would just give us y and then y squared on 8. Maybe not needed, but I found it nice to do. Oh, and we've forgotten our dy's. Okay, good. Okay, let's actually integrate that now. So that's going to be y squared, and we'll divide that by 2, and add 1 to the power y cubed, and that was on 8, and we need to divide by that 3, so we also pop that on the denominator. 0 to 8. Oh, and I did say we were taking out that 2. Okay, I'm going to be especially lazy, and I'm going to take out that 2 again, so that's going to become over 4. And if we take 2 out here, we're going to instead have 3 times 4, which will become 12. And I'll move that down a little bit. Let's get to the point of actually substituting. Still got that pi over 4 out there. We're going to have 8 squared minus 8 cubed on 12. Pop that in brackets, and we're going to subtract. Popping that 0 through, we're just going to have 0. So pi on, that's 64 minus, that's 512 over 12. And if I distribute out that pi on 4, 16 pi minus, I think it's 32 pi on 3. Now we need to get this over a common factor, so we'll multiply that by 3. And then we'll get, oh, that's very nice, 16 pi over 3 units cubed. Now with this question here, it was saying find the exact value of v, and they've told us that v is units cubed. So at some point we need to say therefore v equals 16 pi over 3 to make sure we've actually addressed the formatting of what they asked for in the answer. Because it didn't say what is the volume, it said what is the value of v. So we've explicitly stated that. Let's have a look at another one. Okay, so we've got a shaded region enclosed by the curves. We've got this one, y equals 1 minus cos x, and we've got y equals sine x. So here's our sine x for that portion. It's going in between x equals 0 and pi on 2, or in between y equals 0 and y equals 1. And then on the bottom here, we have that y equals 1 minus cos x. Now I said top and bottom, that's talking about if we're rotating about the x-axis. Let's be careful and see where we're rotating around. So this region is rotated about the x-axis. Okay, so we're going to be rotating it around the x-axis like this. So what I talked about being the top and the bottom, that's perfectly fine. We want to find the exact volume of revolution here. So we know that we're looking at a volume. Good. So the considerations that we mentioned before, we said, was it volume or surface area? We identified for the next question its volume. We identified the axis, and we've identified which graph is above the other. So they're all very important things to do. Volume is going to be pi, and because we're going around the x-axis, we're going to have dx, meaning our terminals are going to have to be where we're going in the x direction. So from 0 to pi on 2. Might need to move that dx because we're going to have a little bit inside of this integral. So the function that we have on top, that was sine x, so squaring that we're going to have sine squared x, and then we're going to subtract, and please make sure you put brackets around it, the 1 minus cos x, and we're going to square that. So please be really careful with your brackets. So there are a few ways you can go about doing this. I think I'm going to expand out that second bracket and see if I can neaten things up a little bit. Okay, so we've expanded that out. Now we've got a sine squared x, and we've got minus 1 plus 2 cos x minus cos squared x. Now, this is looking okay, but I want to get rid of those sine squareds and cos squared situations. So if I put that sine squared and cos squared together, I could have negative cos squared x minus sine squared x, and then we have the minus 1 plus 2 cos x dx. Now, why is that so nice? Well, we know that cos squared x minus sine squared x is equal to cos 2x. So that means we're going to have minus cos 2x and then minus 1 plus 2 cos x. My pen's doing this thing where it connects together my characters. I'm sorry it's doing that. Now, this is something that we can integrate perfectly fine. So cos 2x is going to be negative a half sine 2x. The 1 just becomes minus x. And that 2 cos x will just become 2 sine x upon integrating to 0. Now, we're going to be substituting in nice values. I'm going to have negative a half sine of 2x, and because we're substituting in pi on 2 lots of that will be pi. That's nice because that goes away. We're going to have minus pi on 2 plus 2 sine of pi on 2. And then we're going to have minus negative a half sine of 0 minus 0 plus 2 sine of 0. So all of that goes away. So we're left with, inside of that bracket, we had 2 sine pi on 2, and pi on 2 is 1. So that means we're going to have 2 and then minus that pi over 2. Popping it all together, that means we're going to have 2 pi minus pi squared over 2, and that will be units cubed. Apologies about my pen sort of glitching out as we got further down there. So a really nice question. This one was 4 marks. Not sure of the mark breakdown, but showing you're working out would be absolutely integral to the process. Yes, pun intended. Good luck with your practice.